Hi, welcome back to our channel and back to the tutorial for the tutorial. Back to the channel, and today I'm going to discuss about YOLO algorithm for object detection. So one of the general thing. So YOLO, that means you only look once. So you only look once. That's the meaning. So there will be a versions with the YOLO V3, V5, V7, V8, and so on. Today I'm going to discuss about the basic thing, that is YOLO V3 only. So before going that, you heard now about what is object detection. Object detection nothing but a computer vision task that for identifying and locating objects in images or video also. So I'm going to highlight with this pointer. And before going this one, you have idea about you have confusion about local image localization. It's nothing but process of identifying the correct location of the one or more multiple objects using bounding boxes. And also this example I'm giving here: image recognition, object detection, and image localization. Here, let's go for another one. Let's go for YOLO. So you only look once. It's a state of the art and real-time object detection algorithm. Generally, it consists of 24 convolution layers, 4 max pooling layers, and 2 fully connected layers here. Remember. So this architecture where consists of convolution layer and 3 into 3 into 1 and 1 into 1 126 and so on and so on. This is everything for everything predefined images. If you have pre-trained images, you can go for object detection. So here, remember, so YOLO is a deep group family of deep learning model. Moreover, here it takes the input, it as takes an image as input and uses a simple deep convolution network, neural network to detect object in the image. Here, the architecture works like this only, simple thing. And also here it divides the input image in an n into n grid. And if the center of the object, remember, if the center of the object, this is the input image, and after applying the YOLO algorithm by predicting with the bounding boxes, so and ball also, the players and successors. That is the mode of this one object detection, how it support and work. Here generally, just now tell you, here if the center of the object falls into the grid cell, then grid cell is responsible for detecting that particular object. It may be ball or man or any object. Moreover, each grid cell predicts the bounding boxes and confidence score for these boxes. Confidence score is nothing but the probability of the thing, probability model like this. And also this confidence scores always reflect how confident the model is that the box contains the object and how accurately. It may be 98% or 97 or 85, 75 and so on and so on. Moreover, it can predict multiple bounding boxes per grid cell also, but at training time we want only the one bounding box predictor to be responsible for each object here. And here generally, or how it works, because here generally the architecture follows like this: resize the input image into 448 into 448 before going through the convolution network, and also a first 1 into 1 convolution is applied to the reduce the number of channels as seen in the diagram. The 1 into 1 is applied to reduce, then activation function is that this came under the hood is called ReLU, and some additional techniques also used for batch normalization and dropout here. And how does YOLO object work like this? So once given, like, the result input is there, this is the result exactly, and display the percentage of the or confidence level also. So here this consists of 4 things. One is called residual block, another called bounding box, another called intersection over units, at last non-maximum suppression. First one is called residual block. It's nothing but the first step, always divide the original image into n into n grid cells for equal shape, where n is in our case 4 shown on the image to the right, on the right, just now, so right like this. Then here cross object to bounding box. Here it always determine bounding boxes which correspond to rectangles highlighting all the objects in the image. And also YOLO always determine the attributes of the bounding boxes using a single regression model in the following format, where y is the final vector representation for each bounding box, remember, and the attributes. Remember here, if you go through the YOLO with a lot of things is there, everyone saying some, but this is the common attributes followed in the YOLO v3. You can follow any other. So it consists of PC, Vx, Vy, BH, BW, Atlas C1, C2. Here what is PC? PC always refers to the probability score of grid containing object, and BX, BY and X BX and BY are the X and Y coordinates of the center of the bounding box. Just now showing here the image. So like this, and here it always determine the bounding boxes using a single regression model. Just now told you, and where Y is the final vector representation for each bounding box, and BH comma BY, this is for height and the width of the bounding box with respect to the enveloping grid set. Atlas C1, C2, these represent to the two classes, player and ball, because we can have many classes, but here we are going to see players and ball only as in the image. Then at last, non-max suppression. This is nothing but we can say is a post-processing step. You can say post with that there is need for to improve the accuracy and efficiency of the object detection. Moreover, it's common for in object detection, it's common for multiple bounding box to be generated for a single object in image. So there will be a lot of applications developed with the help of developing with the help of YOLOv3 basics. One is called healthcare. Once go for healthcare, particularly you can say about medical field, that is medical that is kidney recognition in CT used YOLOv3, because with the help of this one we can localizing the kidney in 2D and 3D from computerized tomography. I hope that you understand today what is object detection and what is YOLOv3 and how this work and what is the architecture of YOLOv3 and so on. The upcoming session definitely we go for implementation of YOLOv3 with the help of Dark53, another one, and with the help of Coco data image setters also. If you like the video, please subscribe and share with your friends. Thank you for watching the video. Thank you.